Yes, we have to find the Fourier series for the function f of x is equal to x square minus 2 in the interval minus 2 less than equal to x less than equal to 2, and it is given that f of x is equal to f of x plus 4. Now, first of all, see, this is given that f of x is equal to f of x plus 4. That means here this is a periodic function with period t is equal to 4. So after interval of 4, the function is going to repeat its value. Now, see, it is asked to find the Fourier series. We have to find Fourier series for the given function f of x is equal to x square minus 2 in the interval minus 2 to plus 2. Now, see, this is again an important type. Here we get this kind of questions in the exam. Here f of x is defined as x square minus 2 in the interval minus 2 to plus 2. So the interval is minus 2 less than equal to x less than 2. So see, here the interval is in the form minus L to plus L. It is in this form minus L to plus L. So here in place of L we can see it is 2. See, whenever the midpoint of the interval is 0, whenever the interval is in this form minus L to plus L or minus pi to plus pi, whenever midpoint of the interval is 0, we should check whether the function is even or odd. Here the interval is from minus 2 to plus 2. So suppose somewhere here it is 0, here it is 2, minus 2 on the number line. So midpoint of that interval becomes 0. In such case, we should check whether the function is even or odd. So somewhere here it is minus 2, say, here it is 0, 2 on the number line. So 0 is the midpoint of the interval. In case of this kind of interval is called as arbitrary interval. Okay, see, minus pi to plus pi is a standard case, whereas minus L to L we call it as an arbitrary interval or arbitrary period. So when the interval is of this form minus 2 to plus 2 or minus 1 to plus 1, minus 3 to plus 3, then in that case we compare with this interval minus L to plus L. Here L is 2, and in this case we should check whether the function is even or odd. Now f of x here is given as x square minus 2. To check whether the function is even or odd, we replace x by minus x. In place of x, if you write minus x, it will be square of minus x minus 2. So it will be x square minus 2. Now, if you replace x by minus x, you can see that f of x and f of minus x are same. So therefore, f of minus x is equal to f of x. Since f of minus x and f of x are equal, therefore, we can say that given function is even function. Given function is even, and if given function is even in the interval minus L to L or in the interval minus 2 to plus 2, we don't have to find Bn. Then Bn directly becomes 0, and the formula to find Fourier series is, so if f of x is even in the interval minus L to plus L, in this arbitrary interval minus L to plus L, then Fourier series is given by the formula f of x is equal to a0 divided by 2 plus summation n is 1 to infinity n cos of n pi x upon L. So see, this is the formula to be used when a function is even in the interval minus L to plus L. So we have to find a0 and an. Here bn will be 0. No need of finding bn in this case. Now, so let us find the terms step by step. First of all, we know where that a0 is 2 upon L integration 0 to L f of x dx. So see, we saw that the function is even in the interval minus L to plus L. Here in our problem L is 2. So the formula to find a0 in this case is 2 by L 0 to L f of x dx. If you substitute the respective values, L is 2 and f of x is x square minus 2 into this dx as it is. The 2 upon 2 will get cancelled. Therefore, a0 becomes integration of x square is x cube upon 3 and integration of 2 dx becomes 2x, and that is within the limits 0 to 2. The integration of x square becomes x cube by 3. Integration of 2 dx is 2x. Remember, we have used the formula that integration of x raised to n dx is x raised to n plus 1 upon n plus 1, and integration of k dx is k into x. This is the formula that we have. Now, if you put the limits, it will be 2 cube upon 3 minus 2 into 2. If you put the upper limit 2 in place of x, we'll get this first bracket minus. If you put the lower limit in place of x, 0 cube is 0, 0 upon 3 will be 0, 2 into 0 will be 0. It will be 8 by 3 minus 4. So 3 4 is 12. 8 minus 12 will be minus 4. So you'll get as minus 4 by 3 as the value of a0. Correct? 2 cube is 8. It will be 8 by 3 minus 4. When you put the upper limit, and therefore it comes out as 8 by 3 minus 4. So it is minus 4 by 3 is the value of a0 that we have found out. Now we have to find an. Now to find an, formula to find an we know is 2 by L integration 0 to L f of x into cos of n pi x upon L dx. This is the formula to find an. Now in our case, L is 2, f of x is x square minus 2. Substituting the respective values. So now we are substituting L is 2 and f of x is x square minus 2 in this formula. We have this 2 upon 2 will become 1. We have to integrate x square minus 2 into cos of n pi x dx. Again, to integrate this term, we are going to apply the formula of integration by parts, the shortcut formula of integration by parts, which is integration uv dx is u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus dot 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 dot. So this is the formula that we are going to use. Now in this case, u is x square minus 2. So therefore u dash, the derivative of x square minus 2, derivative of x square is 2x, derivative of 2 will be 0. Therefore u double dash, derivative of 2x will be 2, and u triple dash, derivative of 2 will be 0. Right? So here we are going to apply the formula of u into v. U is algebraic term. So here u is x square minus 2. When u is algebraic term, we can apply this shortcut formula of integration by parts. V is cos of n pi x upon 2. Now remember, dash represents derivative. U dash is the derivative of u, u double dash is the derivative of u dash, and so on. Whereas suffix represents the integration in this formula. V1 is the integration of v. Remember, in general, we know the formula that integration of cos ax dx is sin ax upon a. So that is the formula for integration of cos ax. And similarly, we know that integration of sin ax dx is minus cos ax upon a. Now in our case, v is cos n pi x upon 2. V1 is the integration of v. So it is integration of cos n pi x upon 2 dx. V1 is integration of v. So it is integration of cos n pi x upon 2 dx. We know integration of cos ax dx is sin x upon a. Here in place of a, it is n pi by 2. The coefficient of x is n pi by 2. So therefore this becomes sin n pi x upon 2 divided by n pi by 2. So here in place of a, it is n pi by 2. In place of a, it is n pi by 2. The reciprocal of n pi by 2 gets multiplied in the numerator. It becomes 2 upon n pi into sin n pi x upon 2. Correct? This reciprocal gets multiplied here in the numerator. It becomes 2 upon n pi. That is our v1. v2 is the integration of v1. This 2 upon n pi will take outside, and it will be integration of sine n pi x upon 2 dx. V2 is the integration of V1. Remember, in this case, we'll need term still V3 because we have term still U double dash. U triple dash is 0. We don't need V4. We need V1, V2, V3 because we have U dash, U double dash. U triple dash is becoming 0. So now we are finding V2. So see, V2, that 2 upon n pi will remain as it is. Integration of sine n pi x by 2 will be minus cos n pi x upon 2 divided by n pi by 2. Remember, we have seen this formula that integration of sine ax dx is minus cos x upon a. This coefficient of x gets divided. So integration of sine n pi x by 2 becomes minus cos n pi x by 2 divided by n pi by 2. Here in place of a is n pi by 2. So it will be minus cos n pi by 2 upon n pi by 2. So we get this term n pi by 2. Again, reciprocal of this n pi by 2 gets multiplied. This minus you can take it outside here, minus 2 upon n pi into again 2 upon n pi. This reciprocal of the denominator gets multiplied into cos of n pi x upon 2. So this 2 into 2 becomes 4. N pi into n pi becomes n square pi square into cos of n pi x upon 2 as our V2. We have got V2. Now we have to find V3. To find V3, V3 is the integration of V2. Again, this minus 4 upon n square pi square will take outside. It will be integration of cos n pi x upon 2 dx. Integration of cos n pi x by 2 will become sine of n pi x upon 2 divided by n pi by 2. Integration of cos x is sin x upon a. Here in place of a it was n pi by 2. Again, reciprocal of n pi by 2 will get multiplied. It will be minus 4 into 2 upon n square pi square into n pi. So see, reciprocal of this n pi by 2 gets multiplied, and this 2 into 4 becomes 8. N square pi square into n pi becomes n cube pi cube into sine of n pi x upon 2 as our V3. See, these steps I have shown in detail. After practice, you may skip these steps and directly apply the formula by parts. But it's better to write this so that we don't make any mistake. So now, remember we were finding n, and the 2 upon 2 was 1. It is integration 0 to 2. It was x square minus 2 into cos of n pi x upon 2 dx. We are solving for this integration. We are applying the formula by parts. You see, u is x square minus 2. It is u into v1. V1, we have got it as 2 upon n pi into sine n pi x upon 2. So it is u into v1, then u into v1, it is minus u dash. Derivative of x square, we have seen x square minus 2x, the derivative is 2x, so this is u dash, and this was our v1. V2, the integration of v1, we have seen it is minus 4 upon n square pi square into cos of n pi x upon 2. So see, this is u into v1 minus u dash into v2 plus u double dash, derivative of 2x is 2 into v3. Integration of this term we had seen was minus 8 upon n cube pi cube into sine of n pi x upon 2. And this entire term is within the limit 0 to 2. Remember, this was our u dash, u double dash, u triple dash is 0. So the next term becomes 0. Before we substitute the limits, we'll just simplify this. So this you can write as 2 upon n pi into x square minus 2 into sine of n pi x upon 2. Minus into minus will be plus. 4 to the is 8. So 8x upon n square pi square cos n pi x upon 2, plus into minus is minus 16 upon n cube pi cube sine n pi x upon, and this is within the limit 0 to 2. So see, I just simplified this. This minus into minus I have made plus. 2 into 4 is 8. This plus into minus will become minus. 2 into 8 will become 16. And now we'll put the limits. Wherever there is x, we'll put the limits. You see, we have performed the integration with respect to x. We have to put the limits in place of x. When you put the upper limit 2 in place of x, this will be 2 square minus 2. That will be 4 minus 2 into sine of n pi x upon 2. In place of x, if I write 2, this 2 gets cancelled. This will become sine n pi, which is going to become 0. If you put 2 here, this 2 gets cancelled with cos n pi. Cos n pi term is going to remain. It will exist. And 8 into 2 will become 16 here. Whereas if I put x is 2 here in this term, this 2 gets cancelled, becomes sine n pi. Sine n pi term becomes 0. Similarly, when we put the lower limit 0, this is going to become sine 0. Sine 0 term will become 0. This will be 0 into cos 0, which again will be 0, and this will be sine of 0, which will be 0. So when you put x is 0, all these three terms are going to become 0. So now let us substitute the limits. First we put the upper limit. We put the upper limit 2 in place of x. See this 2 upon n pi as it is. This will be 2 square, that is 4. 4 minus 2 is 2 into sine of n pi. If I put x is 2, 2 gets cancelled, this becomes sine n pi. If I put x is 2, this 8 into 2 will be 16. So 16 upon n square pi square into cos of n pi. 2 gets cancelled. If you put x is 2 here, this 2 gets cancelled. It becomes minus 16 upon n cube pi cube into sine of n pi. So this is when you put the upper limit in place of x. If you put the lower limit 0 in place of x, see this will be 0 minus 2 into 0 minus 2 into this 2 will be minus 4 upon n pi into sine of 0. This is going to be sine of 0 term, so this directly will become 0. Sine 0 is 0, 0 into anything will be 0. Similarly, if you put x is 0 here, 8 into 0 is 0, 0 into cos 0 will be 0. Second term also will be 0, and this is sine of 0 term again, so again it is going to be 0. So remember, sine 0 is 0. So when you put the lower limit 0, all the three terms are becoming 0. The first term becomes 0 because this is sine of 0. Sine 0 is 0, 0 into anything will be 0. 8 into 0 is 0, 0 into cos 0 will become 0, and 16 into sine 0 will become 0 here. Okay. So remember, sine 0 is 0. When we are substituting the limit as 0, this first and last term becomes 0. Second term becomes 0 because 8 into 0 is 0. 0 into cos 0 will be 0. We know cos 0 is 1. This two terms of sine n pi, they will become 0. We know sine n pi is 0. Sine n pi is 0. Sine n pi term will become 0. Only cos n pi term is going to exist. Here in this case, cos n pi we know is minus 1 raised to the power n. Remember, cos n pi is minus 1 raised to n. Only cos n pi term is going to exist. This term is going to exist. All remaining terms will become 0. We are going to get n as 16 upon n square pi square into minus 1 raised to n. This term becomes 0. This term also becomes 0. So we get n is equal to 16 upon n square pi square into minus 1 raised to n as our n. This term is going to remain, and already we had found out a0. We had got a0 as minus 4 by 3. a0 we had got minus 4 by 3. So now therefore the Fourier series for even function, for even function f of x in the interval minus L to plus L, we know is given by the formula f of x is a0 upon 2. You can write a0 upon 2, or you can write as 1 upon 2 into a0 plus summation n is 1 to infinity n cos of n pi x upon L. See, this is the formula to find Fourier series for an even function f of x in the interval minus L to plus L. Now, if you substitute the respective values, our f of x in this problem is x square minus 2, a0 we have got as minus 4 by 3 plus summation n is 1 to infinity. We substitute the value of n we have got it as 16 upon n square pi square into cos of n pi x upon L is 2 in this case. In this problem, L is 2. We substitute that value of L 2. So, we get therefore the required Fourier series as, the required answer for Fourier series is x square minus 2 is equal to this minus 4 by 3 into half will become minus 2 by 3 plus we can take 16 upon pi square outside the summation. Saying this 16 upon pi square constant can be taken outside summation. Summation n is 1 to infinity cos of n pi x upon 2 divided by n square. We cannot take that n square term outside summation as our answer. So this is the required Fourier series. This is our required Fourier series or required Fourier expansion. Right. So see, the interval was given as minus L to plus L. So first we checked whether the function is even or odd. We saw it was even function. We don't have to find Bn, and this is the formula that we have to apply to find the Fourier series. We found out a0, an using the respective formula and substitute the respective values. We get the required Fourier series. This is an important type. So this type of questions are asked in the exam.